Researchers at Johns Hopkins University found 6 proverbial needles in this haystack of the universe, green circles marking so-called rogue planets 950 light-years away.
Hey everybody, welcome to Studio 64. My name's David. I've been searching the interzones for more science, space and tech news to share with you. Came across this at Live Science. Yes, the James Webb Telescope spots 6 enormous rogue planets tumbling through space without a star. Ooh, this should be interesting. The James Webb Space Telescope has discovered 6 rogue planets careening through space without a star. The objects are believed to have formed directly from gas collapse, blurring the lines between planets and stars. Gas collapse. My age, that sounds very familiar. Yes, and here's a little picture here. The Perseus molecular cloud shimmers in this new James Webb Space Telescope image. Isn't that incredible? Nature is an artist. I've said it before and I'll say it again. Fascinating. Yes, and as usual, I'll leave the link to the main article below the video, so you can pop in, check out these embedded links, go for a bit of a deeper dive if you want. Makes for a very interesting read beyond the main article, believe me, it's excellent. Right, so the James Webb Space Telescope, or JWST, has spotted 6 rogue planets drifting freely through space, untethered from the gravity of any companion stars. Now, the planets are wandering through the Perseus molecular cloud 960 light-years away, and range in size from 5 to 10 times the mass of Jupiter. Interesting. I wonder if they're gas giants. Could be very large rocky planets, but yeah, gas giants are interesting. Let's find out. The strange cosmic vagabonds are evidence that the gigantic planets can form in much the same way as stars, congealing directly from turbulent clouds of collapsing interstellar gas, scientists said. The researchers' findings have been accepted for publication in the Astronomical Journal and are available on the preprint server, the one I can never pronounce, ARXIV. Very, very interesting indeed. Yeah, I can say I'm not a scientist myself. I just love all science and sharing it with everybody. Science, space and tech news. I just love it all. And I love all kinds of science, computer science, archaeology, astrophysics, and the way we can combine them. I did a video the other day that was a combination of linguistics, cryptography, archaeology, history. It was just amazing. It was using artificial intelligence to crack the linear A code of this language that was from the Minoans. Check the video out. It's a bit of a long one, but it's really, really interesting. It's something we still haven't worked out because most languages have a common root. So you can say, well, okay, this is this, and we can then basically translate the language using that some common root words or symbols. But in this case, this Minoan language seems to be lost in history. It's quite fascinating. Check it out. It's a good little video. Now we are probing the very limits of the star forming process, study lead author Adam Langeveld said, an astrophysicist at Johns Hopkins University. He said in a statement, if you have an object that looks like a young Jupiter, it is possible that it could have become a star under the right conditions. Is it possible? This is important context for understanding both star and planet formation. Yeah, I remember reading somewhere a theory about how Jupiter was like a star that never made it, if you know what I mean. Like it sort of reached a certain level and that was it. And it's sort of wondering whether the gravity from our sun stopped it. Again, I'm not an astrophysicist, but I've done a video on it where it was something similar with these exoplanets and exosolar systems. And, some stars are sort of held back depending on the amount of gravity from another object. It's interesting stuff. Typically, planets from the leftover gas and dust used in the formation of stars, creating solar systems such as our own. But not every planet is made by this process. Sometimes gigantic planets can form directly from gas collapse, the authors stated. Now, to spot the wanderers, the research used the JWST's near-infrared imager and slitless spectrograph, NIRISS, NIRISS, to peer through the billowing gas clouds and analyse the infrared light profile of every object in the observable portion of the star cluster. Now, using this method, the researchers also spotted a number of known brown dwarfs, the strange objects that are more massive than the largest planets but smaller than the smallest stars, including one accompanied by a planet-sized object. That's interesting. Now, I've got a little bit of a video here to give us a bit more background. Let's check it out, and we'll carry on the conversation when we come out the other side.
You're looking at a stellar nursery, young stars only a few million years old, captured in this stunning image by the James Webb Telescope.
Well, first, the image is just gorgeous. It's absolutely fantastic.
But it's more than just a pretty picture. Researchers at Johns Hopkins University found 6 proverbial needles in this haystack of the universe, green circles marking so-called rogue planets 950 light-years away.
And by this, we mean these objects that are kind of free-floating in space, untethered to any star or any body in space.
Maybe they just form without a star, and they just form like a star, but they have very, very small mass. Or they were, at some point, part of a planetary system, and with interactions, they were kicked out.
To see them, researchers had to use a Canadian tool known as NIRISS to detect light from far outside our solar system.
It was the first time we applied it to study young stars, something in our galaxy.
What they observed helps explain how planetary masses form, whether in disks of gas and dust around young stars, much like Jupiter and our own solar system, or from a cloud of gas and dust untethered to any star's gravity, like these free-floating objects.
Is the solar system typical or rare?
The fact that we didn't find anything below 5 times the mass of Jupiter shows that we are probing the very limits of star formation.
Knowing the size to look for helps narrow down the field in the search for planetary bodies yet unknown.
If we are able to one day travel to these places, what will we see? What will we find?
Questions scientists hope the James Webb Telescope will help answer someday. Heidi Petracek, Global News, Halifax.
That was fascinating, wasn't it? I like that you can see the way they've ringed the planets. Little green rings around them like that to sort of highlight them. Yeah. I just wonder if these planets are fixed or do they travel through space? It's really interesting, isn't it? We use Webb's unprecedented sensitivity at infrared wavelengths to search for the faintest members of a young star cluster, seeking to address the fundamental question in astronomy: how light an object can form like a star. How light an object can form like a star. Oh, okay. Difficulty reading that one. I don't know what the hell's wrong with me today. Brain and mouth are like an old married couple. They're arguing today. Senior study author Ray Jayawardena, sorry about that, Ray, provost and astrophysicist at Johns Hopkins University, said in the statement, "It turns out the smallest free-floating objects that form like stars overlap in mass with giant exoplanets circling nearby stars." Oh, okay. This isn't the first time that the JWST has spotted freely floating planets in space. The biggest haul came in 2023 when 42 pairs of the gas giants, known as Jupiter-mass binary objects, or jumbos, were observed drifting through the Orion Nebula. These objects blur the boundaries between what is a planet and what is not, and many of their masses overlap with gas giants and brown dwarfs. Okay. That's I'm wondering if they, if these objects, if they are, gas giant-like planets or even rocky worlds, if they have any value, if the gas could be mined for some particular reason, or the rocky worlds have some sort of minerals that could be mined in the future. That's very interesting, isn't it? It's likely that such a pair formed the way binary star systems do, from a cloud fragmenting as it contracted. Jayawardena said, "The diversity of systems that nature has produced is remarkable and pushes us to refine our models of star and planet formation." The researchers said their next steps will be to follow the objects with the JWST, studying their atmospheres and compositions for clues about their formation and how they differ from other cosmic objects. Yeah, so atmospheres and compositions. So, whether they're rocky worlds or gas worlds, and if they have an atmosphere, and is it possible that they could have an ocean on them, under the surface, like moons of Jupiter and Saturn? That'd be very interesting to find out, wouldn't it? These little floating bearers of life in space would be very, very interesting indeed. It would certainly change the way we look at the possibilities of life and the extreme conditions in which life could exist and form in the first place. Yeah. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. I'd greatly appreciate it. If you're up for it, drop a comment down below the video, because I'd love to hear what you think. All right, take care, and as I always say, if you can't be good at it, and as I also always say.
Fascinating, but quite impossible.